Manhattan Policeman. In Manhattan, the streets are all in blocks as shown below. So these will be the buildings and the roads going between them. A policeman on duty is able to observe a distance of 1 block only in any direction. So for example, if we have a 1 by 1 block like this policeman can see up to the next junction in that direction and that direction. And this one here, in this 1 by 2 block, because it has 1 row and 2 columns, he can see down to this junction, across to this junction, and across to this junction. And here we have one in a 2 by 2 block. A 1 by 1 block cannot be covered by just one policeman, because two sides cannot be covered, as we can see in this diagram here. To cover a 1 by 1 block, we would need at least 2 policemen. So 2 would be the smallest number of policemen to make sure that we can see every junction. We could cover a 1 by 5 block as shown below. This would certainly cover it, but are all of the policemen necessary? I would suggest they're not. If we look at these 2 policemen, they're actually covering the same side here. So we could get rid of one of those. If you do not believe them all to be necessary, draw a better arrangement below. Use the minimum possible number of policemen. So, this would do the trick. If you draw arrows on all of these, you'll see that they would cover all of the roads that we can see. So here and here, and along here, this one covers there, this one covers there, there, and the outside. So everything is covered by those policemen. So we can cover the 1 by 5 block with 6 policemen. And we saw before that a 1 by 1 block was 2 policemen. Find the smallest number of policemen needed to cover a 1 by 8 block. So how could we do this? If you drew arrows on here, I think you'd see that these policemen drawn would do the trick. So we can cover the 1 by 8 block with 9 policemen. Investigate some other 1 by n blocks and then complete the table below. So it's your task now to go away and actually draw some of these on your investigation. And then we'll complete the table. What have we seen so far? We saw this took 3, 4, 5, and we can see in every single case that it's 1 more than the number of columns. So, for 100 columns, a 1 by n block would take 101 policemen. This would be 1001, so we're always adding 1 to the number of columns. So if we have n columns, then a formula would be n plus 1. So moving on to the next part, a 2 by 1 block, so that's going to have 2 rows and 1 column, could be covered as shown. But are all the policemen necessary? Well, once again, I think we can see that they're not. If we don't believe them to all be necessary, draw a better arrangement below. Try to use the minimum number of policemen. So I think we could do that like this. Is that the same as a 1 by 2 block? Yes, a 2 by 1 takes 3, the same as a 1 by 2. On the diagram below, draw an arrangement for stationing policemen on a 2 by 3 block using the minimum number of policemen. I think we could do this. Perhaps you should investigate to see if you can do better. I'm not drawing arrows on all these diagrams, but I really suggest that you do, so that you really get the idea of how we're covering the blocks with these policemen. So now we want to look at a 2 by 5 block and a 2 by 7 block. So I'm going to leave you to do that. You can draw those and do that. and then complete the table below. Let's put in the results we have so far. We had that this was 6, and that's the only result that I worked out. We've given the 3 here, we did look at that. So you're going to do the 2 by 5 and 2 by 7 and see if you can spot a pattern to complete the table. Once you've completed the table and seen the pattern, you should be able to predict forward for 99 columns and 999 columns. A 3 by 1 block could be covered as shown in the diagram below. Are all of these policemen necessary? Well, by now you should know they're not. If we don't believe them to be necessary, draw a better arrangement. So what could be a better arrangement on here? I'm going to leave you to do that. But is it the same as the result for a 1 by 3 block? Remember, this is 3 by 1 because we've got 3 rows and 1 column. I think you'll find that it is. On the diagram below, draw an arrangement for stationary policemen on a 3 by 2 block. So once again, you're going to be left to do that. Is that the same as the result for a 2 by 3 block? Well, look back at your results. Investigate some longer 3 by n blocks and then complete the table on the next page. Just for example, I'm going to do a 3 by 3 block here. So I could put a policeman here who would cover those sides. Could put one here who would cover those ones. If I put one here, he could cover these. One at the bottom could cover these sides here. Let's put one here to cover there. One at the top to cover these ones. And that leaves me needing one here and one here. So we can see that that's 8 altogether. So here we have a table for 3 by n blocks. So we discovered that this one was 6. And we've just seen that this one was 8. And now you can go ahead and complete the table. And then we'll see if there's a pattern. So once we've seen the pattern, we can then answer these questions. How many policemen would be needed for a 3 by n block if we have 30 columns? So you've got to extend your pattern on or come up with a formula. Or 100 columns. The relationship between the number of columns and the number of policemen when we have 3 rows can be stated as a word equation. The number of policemen is going to be some number times the number of columns, add another number. So we want to find the value of A and the value of B. And sometimes it can be easier to do this before you do these ones. It's easier to find these sort of things with a formula than it is just to count forward from a pattern. So look at this really closely and try to come up with the correct formula. Once you've done that, we're going to make it into a proper formula without writing things like number of policemen by using the symbol P to represent the number of policemen and C for the number of columns. So we'll end up with a formula of the form P equals AC plus B, where A and B are the numbers that you're going to find. Now that's the end of the take-home part, and I'd like to think that you would get this done at least a few days before the in-class part, so that you have time to start thinking about things that could be asked in the in-class part. We've looked at things like having 1 row and multiple columns, 2 rows and multiple columns, 3 rows and multiple columns. What do you think could be asked in the in-class section? Try to predict it. Work with different families, different numbers of blocks in the rows, and see if you can come up with formulae. And that's how you're going to do well in the in-class part.